I received a question dealing with this particular problem on mastering. So let me run through a little commentary about how we handle the F block on the periodic table. There's not going to be a lot of these on the test or the homework set, but there's a few showing up. And so the way this problem is set up is asking you for the the abbreviated electronic configuration for uranium. So let's just sort of do that from scratch using a periodic table here. And we want to find uranium. Okay, so uranium is right there. And so that means, right, if we had to do a full orbital diagram, we would take up a lot of ink. But we don't have to do that. Instead, we want to do the abbreviated electronic configuration. So if I start 92 to 90, 89 to 87, 86. So the first 86 electrons can just be represented by, well, let me put up here, just radon. Okay, radon in brackets, that represents 86 electrons. That's convenient, right? We would call this, or these electrons, the core electrons. And remember, the way I'm treating this language is that whatever's in the block here is the core electrons, and up here are the valence electrons. In chapter 8, we refocus our attention. We modify that just a little bit. Okay. So there's the noble gas configuration, and now we want to deal with the remainder of there's only 6 electrons left over after this, right? Okay, so what do we do? 1s, 2s, 3s, 4s, 5s, 6s, and all the way down to 7s, right? So we're way down on the periodic table. It's also include this little section. Notice how and this is what can be a little tricky here for the F block. Notice the way the periodic table is set up, 87, 88, 89. This is actually implying that one electron gets placed in the D sublevel. And that's what we see in the answer here. There's that one electron on the D sublevel. We see it's 6D here. Let's map it on the periodic table. Remember, this would be 3D, 4D, 5D, and 6D. How do we handle the F block down here? Well, and actually let me just ink this one in. Right, each time a new sublevel is added, you have to get to one higher principal quantum number. What does that look like on the periodic table? What it means is that the S block starts at 1, the P block starts at 2, this one starts at 3, this one F block is going to start at 4. So 4F, 5F. So let's just walk through the sequence here beyond radon, okay? So we're starting at francium. That means we're going to go through the 7s sublevel, 1, 2. And then notice, again, the atomic numbers, how it's laid out. And 89 is here. That means that it implies, and this is how we treat it, there's going to be one electron in the 6D sublevel before we move down to the 5F. Why do I move down to the 5F? I'm just simply counting up 87, 88, 89, 90, right? Ascending atomic order. That's how I keep track of the pattern for the electronic configuration or orbital diagram or abbreviated electronic configuration, whatever you're being asked for. How many electrons are in the 5F sublevel? There are 3 electrons in the 5F sublevel. There's 1, 2 here, and there's 1 there. And that's what we see in, again, what I'm going to call the valence shell, this what's above the core group. And notice how I'm doing this. I am going to lay it out how I see it. Okay, now, mastering chemistry can be a little picky about this. Now, honestly, like on a test or something, if it was just a handwritten problem, I'm much less concerned in terms of the sequence. But computers are kind of dumb, right? I mean, they're just looking for, like mastering chemistry, for example. It's being told that the correct answer, you go from 7 to 5 to 6. Okay. For me, either way is fine. Whether you start with the, like, here the 5 and then the 6, and then here the 6 and the 5. Switching it up, it doesn't really matter to me in the context of a test or a written assignment. And Mastery can get a little picky in terms of the sequence here. If it does that, just be aware that it can do that. And, if it counts off a lot of points, let me know.